Hello everybody and welcome back to another session at the VBS Tech Conference. I am Pete Morrison and for this session I'm joined again by Mark and Ollie, our moderators. If you guys could just turn on your video for a second. That's Ollie and that's Mark. All right, thanks guys. So this is going to be very similar to yesterday in terms of how we run this. The system is called Demio and you should see that you have a private message chat box and you can send the moderators private messages. You can send questions. Everything will be anonymous. No one else will see your questions and you can type questions throughout the course of the presentation. So today we're going to be doing a deep dive into VBS Geo, VBS Plan and VBS Control. Today's session is going to be a bit longer than yesterday. We're going to go for about an hour and a quarter. And that's primarily because I've asked Martin Kolombo to join us. You'll see him at the end when we get to that section because I think VBS Control is a really interesting technology and I want to spend some time with that. Tomorrow we're going to do this integrator session. It's going to be really cool. Mark is going to run that. We're going to talk about the SDKs. We're going to talk about the APIs, AR and VR, the content import tools as well. So let's kick right in now. And first I want to talk about the VBS World Server again. So we described this yesterday. The VBS World Server is, and by the way, I should say that I kind of am anticipating that most of you did see yesterday's session. If you didn't, then it is available on YouTube under our public channel under BISim. But the World Server, it's a free add-on for VBS 4. It allows you to store your terrain data centrally, and the VBS World Server streams high-fidelity terrain data down to VBS 4 and VBS Blue IG instances. And just to kind of recap, the VBS World Server is underpinned by the World Server technology. The VBS World Server that's shipped with VBS 4 is an application that streams terrain data down to VBS 4. The World Server technology is a set of technologies that allow a really fantastic enterprise solution for storing and streaming terrain data. And so the diagram that you see on the screen describes the World Server technology in general. And I just want to make that really clear. I didn't really do it yesterday. There's this distinction between the VBS World Server with VBS 4 and what the World Server technology under the hood is capable of. So the diagram here describes the World Server tech. You can see that we have different terrain ingests, Bing and Vricon, various GIS formats. We have a Geo server sitting as part of the World Server, and we can connect different runtime engines into the World Server, be it simulation engines or game engines like Unreal or Unity, MCIS or browser-based applications as well. So we have this really powerful enterprise framework that we can demonstrate and talk about. If you're interested in this, please get in contact with us and we can talk about this in more detail. So the version of the World Server that comes with VBS 4 can't do everything here, but we can certainly package up a version that can, if that is of interest to you. So that's it about the VBS World Server. So what I want to do now is talk about the plugin system and the optimized cache. Now, as I described yesterday, the VBS World Server, it's a really powerful capability and it does procedural refinement both on the server and in the runtime application VBS 4. So most procedural engines, which are refining terrain data at runtime to make it look really high fidelity, think about computer games like No Man's Sky or Kerbal Space Program or Star Citizen, they're doing this procedural refinement only in the engine. It's like a cute engine trick that's highly proprietary to that engine. That is not what we do. The way we procedurally refine terrain on the server can make that procedurally refined terrain available to any connected runtime engine, really solving terrain correlation issues. It's a really flexible approach. Now what I'm going to do is run a video. Unfortunately, I'm not going to do any live demos today. I love live demos. Our technology is almost ready. It's being released in July. I really wanted to show it off live, but yesterday the streaming performance was just too poor. So we did the next best thing. We recorded a couple of videos. We did this over the last 24 hours, and that's what we're going to show you here, just so the quality is really high. So the video I'm about to play will run for about 20 minutes. It's first going to describe in quite some detail the plugin architecture that's running both on the VBS World Server and in VBS 4, and then it's going to deep dive into VBS Geo. Now, while the video is playing, you can continue to ask questions in that chat. We'll do our best to answer them while the video is playing. If not, we'll kind of capture them at the end. So I'm going to kick that off now, and I'll see you in about 20 minutes. So what you can see on the screen, you're not going to be able to read anything, is the flow graph showing the various plugins that create the procedurally refined terrain on the VBS World Server and on the VBS Blue engine. So we can zoom in and we can kind of see many different nodes here. And in general, what you're seeing are plugins into the VBS Blue engine or VBS World Server that describe how the engine or server should process various data types. And so the idea here is that the engine is just a thin rendering layer, and these plugins are actually telling the engine how to ingest and render data. And it's a very powerful system, and it runs at runtime as well, because if you think about some terrain deformation events, for example, that's a runtime event. And if we have a crater in the terrain, obviously we're going to want to see that across various different data sources. If we have a crater explode on a road, that's going to impact the surface, which might look like the road. It might impact the height field. It might impact the biome or the vegetation. So we have plugins like the crater plugin that cuts across other plugins. Now, this system is not designed as yet to be used outside of Bohemia. We might one day open this up, but I do want to just make sure that you understand the power of the system that is under the hood. So if we're just going to load up VBS really quickly now, I'm just loading it up what we call offline. It's just going to load up directly from my computer. And I'm just going to give you a quick example of the power of this system. So we're loading up VBS 4 here. It's just going to take 10-15 seconds or so to bring us into the main menu. And there we have it. And we're just going to go to a specific location on Earth. We're just going to go to Coffs Harbour, which is my hometown in Australia. So we can just quickly search. We're using Google in the offline build here, and we're just going to spin the camera around. And we're viewing Coffs Harbour in Australia, fairly low altitude here. And so what you can see is, well, first off, that this area of the Earth we haven't really built out. There are no roads, there are no buildings, but you can see that there's this procedural texture data. We're kind of calculating this texture data. This is obviously forest, this is obviously open area, and it looks pretty good from high altitude. And so this is our procedural surface texture. So we're just going to close down VBS 4 now. We're going to come back to that. Now here we can see that there is a collection of plugins. This is actually the collection that creates that procedural surface texture. And if we replace that, for example, with imagery direct from Google, we're just going to save this plugin and just restart VBS 4 here. We're immediately going to see a very different view of the terrain, because we're going to be downloading tiles from Google Earth and using that to texture the terrain. Obviously it's going to be geo-referenced. So let me just go back to Coffs Harbour now. I've just restarted VBS 4 here on my local machine. And again, we're loading this terrain data from my local machine, except for the Google Earth data, which is obviously coming across the internet. So we're going to go back to Coffs Harbour, and what we're seeing here, this texture data that we're seeing, is no longer the procedurally created texture data. It's actually streaming the data in from Google Earth. So yeah, it looks completely different, obviously. But the point here is that the World Server and the VBS Blue engine, through using this plugin system, is extremely flexible. So we can just bring in different data sources really fast. And it was exactly the same with Microsoft Bing data, for example. We have a specific plugin which we just connect to the Microsoft servers, and it just starts populating VBS with data. So that's a quick look under the hood at the VBS plugin system that's running on the server and in the VBS Blue engine. Okay, so we're going to reconnect now to the VBS World Server and relaunch VBS, which means that we're going to be downloading our terrain data from the World Server, not from my local PC. So I've now spoken about the World Server in general. I've given you some context and described how it works. We're now going to look at VBS Geo in a little bit more detail than we did yesterday to do a bit more kind of advanced terrain editing, but still you'll see it's quite easy to use. So for this next session, we're going to be in Fort Carson. So we're going to navigate there now and it'll pop up pretty quick because there's not a lot of terrain data here. So this is the area that we're going to be working in. So we're going to load up VBS Geo within VBS 4 straight away. So what you're seeing here is the 20.1 kind of pre-release, still heavily work in progress, but it will give you a really good feel for what you can do in the July release of VBS 4. So here we have some terrain. It's pretty bare at the moment. So we're just going to import some different data sources just to give us a starting point. And so we do that through the import data dialog. We can select our data type. So we're going to start here with surfaces, and then we simply select a file. So we're going to select some surface data here, which the guys at VBSim prepared for me. And it's just going to take a second, and then I can click OK. So what it's doing is actually, it's sending that data to the World Server and doing an import process. So surface data really defines material textures and such. Using our tool TerraTools by VBSim, you can really do this quickly using a tool called Material Map. It looks at an image of an area and automatically figures out where the trees are, where the dirt is, and so on and so forth. So that's what you're about to see. And any GIS analyst or any GIS expert can do this kind of work. So really quickly there, you can see that we've just imported an improved surface definition. So we've got some more fidelity in where our trees are. You can see here that we've got some dirt and some areas where buildings will also be imported in. So that's our surface data. Let's next bring in some imagery. So again, we're just going to go in, select the data type, and we're going to select, it could be aerial photography, I'm not really sure. We're going to select this, this geo-referenced image in the GeoTIFF format, and then we're just going to import that directly into the application. Now this is going to take a little bit longer because the data is pretty big. But if you remember yesterday, if you were attending the intro sessions, we actually flew over to Kingsville, where we'd used ultra high resolution texture to map onto the terrain. And you could do the same thing anywhere on Earth. If you have the geo-referenced image in the GeoTIFF format, which is exported by many different GIS applications, you can import that directly into VBS Geo. And just while we're waiting here, it's going to take about a minute to get this import process done. I'll just point out the difference between VBS Geo and TerraTools. So VBS Geo is perfect for these relatively small area terrains. We haven't actually put a hard limit on the size of the data you can import using VBS Geo, but typically, because it's a what you see is what you get tool, I'm guessing kind of 5x5, 10x10 kilometers, depending on what exactly you want to do. And then you would use TerraTools from VBSim to build out bigger areas like geotiles or many geotiles, or if you wanted to modify the way the procedural generation works, then you would use TerraTools. Okay, so we've now imported that high resolution imagery. You can see that our trees here are mapping pretty well to the underlying texture data. Quite high fidelity biome here. We're in Colorado, obviously. So next, let's bring in some buildings. So we can see here that we've got the buildings visible in the image, but obviously not in 3D. So again, we can go back to import. We can select our buildings, select our file, and in this case, it's just going to be a shapefile with vectors for the buildings. And the system will extrude those buildings and automatically apply a geotypical texture to them. So we're going to click OK. So now we've sent that vector file to the World Server, and it's being processed, and we're going to see our buildings get automatically extruded. So again, this is going to take a little bit of time. So the interface itself, we've designed to be used by anyone. We're hoping that no training course will be required. And this tool will also be collaborative before the end of the year. So I've loaded into the battle space. I'm obviously editing the terrain. We want to support multiple administrators doing this at once. which will allow you to really accelerate the development of terrain. So if you've got something like a brand new terrain area, all you've got is the reference imagery, maybe you want to use Google or Microsoft Bing as the backdrop, and you're literally just tracing over roads and buildings, then clearly the more people that you have doing that, the faster you can build your terrain. Okay, so here you can see that we've just extruded these buildings from the vector files, and that has automatically populated the terrain. So now we're going to go in and have a look at some of the specific, what you see is what you get terrain editing features that VBS Geo provides. So before we get into that though, let's just have a look. I've just kind of changed the camera position here, and I thought it'd be interesting just to kind of show you what this looks like from space, because we always want to make sure we have this kind of smooth level of detail transition from space down to blades of grass. So we can actually zoom all the way back in here, and we've done a lot of work to make sure that we get this realistic representation at any altitude. And I also do want to point out that we do support the import of 3D drone data in a very similar way. It's just not going to be exposed through the interface in 20.1, but we'll have that there by the end of the year. So if you've collected some 3D data using a drone, you'll be able to import that directly into VBS Geo as well. And now we're ready to start editing the terrain in a what you see is what you get manner using these tools here on the left. We got a sneak peek at that yesterday, but let's dig into that in more detail now. So here you can see we have our extruded buildings and our roads that were previously imported. The first thing I want to point out is that we can actually modify anything that's existing in the terrain. So we can come in here and we can delete these existing buildings, for example, if we wanted to replace them with hand modeled buildings. We can also modify any of the roads that might exist in the terrain database. So here, for example, you can see that we're missing a little bit the underlying terrain data, so we can actually come in and modify the position here of this road, for example, manually change where the road is located, and this will be saved along with the battle space with all the other terrain edits that we're doing. So this is quite powerful and really quite easy to use. So let's have a look at some of the other features here. The first one will be height field modification. So we can come in and just select an area using this tool, as you can see here. We press enter to select the area, and we can just raise up that area of terrain, which will automatically also raise whatever objects is upon it. So we can see we've just created this kind of raised area now. And like I showed yesterday, we can do trenches very easily as well, just using the line brush. We can come in and obviously move the terrain down as well, and that's what you can see here. We've just created a trench in this terrain, digging directly into the ground. It's worth noting that we also have a history brush. This is kind of a regionally specific undo, so we can just undo the changes for a certain area if we wish. So next we have our model placement. So model placement, again, you saw yesterday, we can come in and we can place models on the terrain from a very extensive library, and you will be able to add your own models to this library obviously later in the year. So first off, we'll come in and just place some buildings. We'll zoom in, and we've just selected some options here to give us random scale and rotation of these particular buildings. I can obviously toggle that on and off here in the top right. We're doing linear placement as well, so if we move to maybe this road over here will be interesting, and we want to place, for example, a wall along the road, we can just do that in a couple of clicks. So that's basically what I'm doing here. I'm just kind of placing a wall along the road. We'll do it all the way down to here. Maybe do a bit of a curve. So I'm actually doing curve editing now. We're just going to kind of bring the wall around the bend and press enter to save that wall right there. So you can see that we've just created this wall directly into the terrain here, and it takes care automatically of the segment placement. We don't see any overlaps. It's perfectly defined for this specific wall. And of course we can edit the wall that we've just placed just by kind of clicking on it, and you'll get various points that you can actually just drag the wall and change its location. We can do different types of linear features. So, you know, here for example, we're going to do, if I select it correctly and select place, If I press the right buttons, that's just a different type of linear feature that we've created. And down here we have another one as well. I've just actually changed my sandbags into a set of houses. Let me just kind of correct what I just did wrong there. So what we want to do is just come in and in this case we're going to just place down a row of houses. So yeah, just with clicking we can draw a row of houses, as you can see. And we also support editing of these linear features. So if you click on one of these definitions, you can see that you can actually change the objects that comprise that linear. So you could do things like power poles or any range of linear features. Bridges, for example, made of bridge segments as well, will be supported in the very near future. So that's linear placement of objects. Of course, we have a stamp as well, so you can come in and just sort of stamp vegetation kind of randomly around an area, as you can see. And obviously the obligatory erase tool for kind of undoing whatever it was that we did, even though it's working there on the stamps in this particular example. So road editing is important within VBS Geo. So here, for example, not all of these trails came through when we imported the underlying terrain. So for road editing, you're simply coming in and you're using the interface just to place new roads. So here we can just left click again on the terrain, left click, we can enter what we call curve mode and just kind of easily ensure that road kind of curves as we want it to in a kind of realistic fashion here. It's quite easy to do using the keyboard shortcuts. I'm certainly not a terrain editing expert, but even I can place down quite a good looking road as you can see. So we just press enter here and that just creates the road in the virtual environment. Now this road will be path planned automatically. We could jump into the game, and in fact that's exactly what we're going to do in just a little bit, and we could drive along this road. In 20.1 you are going to be fixed to these specific road types. 20.2 it's going to be opened up a lot more. You'll be able to add your own road surface definitions with no problem. And finally now we have surface editing. You did see a little bit of this yesterday if you attended the introductory session. We can select an area of terrain, just like I'm doing here, and press enter and then change the type of terrain that we want to see displayed. So we've just obviously created a little forest here. The trees aren't on the roads. And it's quite high detailed. Now this forest is no different to any of the other forests in VBS 4. All the trees are 3D, they're all destructible, they provide obstacles for artificial intelligence, and you can place these anywhere you wish with as many trees as you wish. And we also support an eyedrop tool as well. So for example here, if we come back and we draw an area like this and we press enter, we can actually use the eyedrop to select a different surface type. So that's what I'm going to do over here. I've just selected grasslands, click apply, and it's just turned that area into grassland. Using this little eyedrop tool here, I was able to select an existing surface directly from the 3D terrain. Finally now we're just going to have a look at this in preview mode. So at any point in time while you're editing terrain you can actually jump into the scenario. So that's what we're going to do now. You can put down a vehicle or a character. You can test the path planning using the AI. You can just run a VBS scenario on top of the terrain edits that you've created. So just in a few moments here we're going to be operating from the perspective of our Australian soldier here, and we're moving through this kind of weird little village that we created with a couple of clicks, buildings of all shapes and sizes. Look at this one, this is a very cute little one. And I'm not really sure where my road is, so we're going to go into the real-time editor here, and we're just going to move the character towards our road. So we'll just come over here and back into first person. So what we should be able to find here is the, here it is. So this is the elevation edit that we made. directly into the terrain. We've got our trench over there to my right. I'll just kind of accelerate time here, and we can see that this is the road that we created. Now this is a dirt road, so it's actually not cutting through the terrain. If this was asphalt, then it might actually just cut directly through the small hill that we've created here. So that's it for the VBS Geo demo. You can see it's quite an easy to use tool. In not much time at all, probably 20 minutes or so, I've been able to import the base terrain data and then run through all of the different tools that VBS provides to edit the terrain. So just to finish off, just a couple of words about how terrain is saved in VBS 4 20.1, which is the July release. All of these edits that you see me making here in VBS Geo will be saved with a battle space. And so a battle space, just in case you missed the introduction yesterday, we'll go all the way out to the main menu here. So a battle space is a collection of training content. So our changes there, if I'd actually saved the changes, would have been saved as part of this battle space. And if we unloaded a battle space and loaded another battle space, the changes would disappear. And this is intentional. It means that your terrain edits are battle space specific. In 20.1, you will be able to copy your terrain edits from battle space to battle space, but it won't be until the end of the year that you can actually save your terrain edits to the base terrain layer. And we'll introduce some kind of versioning system at the end of the year as well. So that's how these geo edits are saved. We think this is a very powerful system, and I should also mention that we're intending to support collaborative editing within VBS Geo before the end of the year as well. So you can have multiple human participants in there modifying the terrain, placing down roads, placing down buildings, just accelerating the process of building out terrains. All right, so that was the VBS Geo deep dive. Please feel free to ask your questions. I was able to answer a couple, but then I got distracted. But we're marking your questions and we're going to answer them at the end. So please don't worry if we haven't answered you directly in the chat. So now we're going to look at VBS Plan. So again, I did an introduction to this yesterday. So we're going to dive directly into another 20-minute video to look at this interface in some detail. I will remind you that this is a really easy to use mission planning capability built into VBS 4. It's another one of these editing modes in the prepare phase, designed for a commander or an administrator to really quickly create a plan. So I'm going to kick off the video again now. It'll run for 20 minutes. Please keep asking your questions, and then we'll get into VBS Control. We're going to pick up where we kind of left off yesterday. So if you attended the session yesterday, you would have seen us create this little defensive position for the opposing forces, and we're going to conduct an assault. We're going to have some M1 tanks providing support by fire from this direction, and the assault itself will come from this direction. So I've already gone through and just placed the markings the same as we had yesterday. So as you can see here, if I can just move the camera, we're going to have an M1 tank platoon moving into position here and a mechanized infantry platoon conducting an assault from this direction. So let's have a look at this interface in a little bit more detail. So you can see here in the top left that we have drawing and tactical. Now drawing means that I'm simply placing drawings in 2D or 3D that don't actually have any tactical meaning during execution. These drawings will be visualized, different participants will be able to see these drawings, but it's not going to create 3D units if we place down various military symbols here, for example. And then we have this tactical mode. So this tactical mode means that the drawings that I place have some kind of tactical meaning during execution. If I've placed down military symbols, then 3D units will be created accordingly. If I place down maneuver orders, then behavior will be created accordingly. So let's start by looking at the drawing tools. We're going to move over here and we can see that there's a range of different drawings we can do. For example, we can do 3D drawings. We can do an air corridor here. I'm just going to kind of do an air corridor through here like this. And we can visualize that air corridor in 3D as you can see. It's possible to kind of change the drawings. As you can see, I'm just dragging these nodes around to change the drawings after they've been placed. It's also possible to do things like polygons, so we can come in here and just kind of draw a polygon around an area of this forest, for example. Just like that. And then we can change the shading of the drawing, so we can come in and give it a different meaning depending on the shading that we choose, just like I did right there. And there's many options available. We have text tools as well, so we can actually just draw text on the terrain, and we can see that in different ways. So there's our text, which have been rendered there in 3D, and we could of course see all of this in 2D. So there's our air corridor here, and there is our text. Of course, we also have a wide range of military symbols that can just be drawn. So we have the full 2525 library here, air assets, space assets, anything that you might want to place into your scenario, you can. But again, these are simply drawings. It's not going to actually create a B-2 bomber or something. It is an icon that we've simply placed down here on the terrain. We also support line drawing, so we can come down here and change the type of line that we're drawing. So for example, an obstacle, buried obstacle, and we can just draw that directly onto the terrain just like this. And we've made sure that you can sort of see these from all directions, up very high, down low, and of course in 2D or 3D. Overlays are included to help you manage your drawings as well. So up in the top right here, you can see this is all the drawings we've done so far are in this overlay. We can change this, give it a different name, and add a new overlay. For example, let's call this one Op4. Now it's possible to hide the first overlay, the blue 4 overlay, and now we're working in this Op4 overlay, so we can just place down some different. There we go. So there's an Op4 icon here, and that's being done in the Op4 overlay. And we can obviously toggle that on or off as well. And it's also possible to lock an overlay just to prevent edits to it. For example, prevent editing it accidentally, because you can obviously edit multiple overlays at once. And if you want to lock a single overlay, then that's very easy to do. Now, overlays can be shared, and this is an important capability which we are expanding this year. The idea here is that maybe you don't want the Op4 overlay to be seen by the Blue 4 users. And we're doing an amount of work for a US government customer at the moment to kind of greatly expand this to really facilitate collaborative editing of the plan, where you can do overlay sharing really, really easy between participants. And I would also say that the vast majority of this drawing capability that you see here was originally funded by the Dutch, and we're very appreciative of that. We've taken that basic concept in the VBS chalkboard, we've brought that into VBS Plan, and then expanded the tactical elements. Now we're back looking at our original set of units and maneuver orders. And we're going to look at the tactical side of VBS Plan. So you've already seen me place down different units. This list will grow, like what you can place in VBS Plan dramatically over the course of the year. And in fact, in the 20.1 release, you'll see different ORBATs available here for the US Army, US Marine Corps, Australian Defence Force, the Brits, the Swedes will all be added here in the 20.1 release. And then later in the year, we'll actually add support for an ORBAT editor, so you can actually do this real time within the product. I'll talk about our plans in a little bit. So some of the other features of this particular technology include a line of sight tool. This is being expanded dramatically right now. In 20.1, it will allow you to do line of sight from a large number of different units on the map. For example, show me areas of dead ground, so it's easier to do planning. We'll also show range rings for at least the primary and secondary weapons for the given unit. So we can do line of sight from a specific unit, and we'll get an indication of what their weapon ranges are. And this is obviously very important to make tactical decisions. Now, any of these features could be turned on or off. So you might be thinking, well, if I'm training my cadets at West Point, then maybe I don't want them to have access to all this information. And that's totally fine. It would be relatively straightforward for us to provide a variant that doesn't have all of these additional capabilities. But what we want to make sure in the base product is that an administrator has all of the tools needed to put down a workable plan in order to facilitate really good training. That's what our objective here is. Let's look at control measures. So yesterday we added a phase line, and I'll just do that again right now. So the phase line can be as long as you need it to be, and it can cross as many maneuver orders as you need. Now, phase lines have tactical meaning when we actually create the artificial intelligence here. And I'll just minimize some of this to help us see. Over here you can see we can give the phase line a time, and down here you can see the phase line is visible on the timeline. So as we increase the time of this phase line, you can see the timeline changing, because what we're doing is saying that we do not want any of the units to move across the phase line until the certain amount of time has passed. That's basically what that is saying. It allows you to synchronize really large maneuvers. Like in the scalability test, we did the 2,000 entities. We had an entire brigade all synchronized using these phase lines, and it worked really, really well. So that's how the phase line works. And obviously the timeline is interactive, so we can change and drag how long we want our support by fire. We can't change the length of the assault because that's set kind of from doctrine, and it's going to take them that long to assault the objective. If we were doing an armored assault, it would be much faster, but because this is a mechanized infantry assault, it's going to take some time. Now, these timings in the 20.1 release will be quite accurate. We take into consideration planning time, form-up time. We take into consideration as well any significant path planning they have to do. So, for example, if this mechanized infantry platoon had to navigate around this forest, that would take extra time, and we would factor that in. It's not going to be 100% accurate, but it's going to be pretty close. And of course, the timings here don't take into consideration enemy contact. So if an enemy fires, if an effective fire is taken, then the timings do go out the window a little bit, but that's exactly what happens in the real world as well. So that's a phase line and some timings here. We've also got control measures in the form of boundaries, so we can do boundary lines if we need to, and just change very easily the type of echelon that boundary is for. This doesn't have any real tactical purpose in the current version of VBS. Eventually we'll probably make this meaningful in that the AI won't actually cross the boundary in their path planning. We've already covered the objective tool. You can have multiple objectives, and that's linked into the support by fire. So the support by fire here, you can see selected order properties, objective OBJ. This is objective OBJ. So we can make sure that entities are firing at the correct target. And finally now, we do have some different menus up here. This is where you would import your MSDL or a different previously saved VBS chalkboard plan directly into the product. And we also support import of different overlays. So if you did want to import a raster overlay, you can do that right here. For example, a military topographic map. But for now, what we're going to do is build this mission. So when we click Build Mission, it creates all of the 3D content for the scenario. So after just a couple of seconds, what you can see here is we have our tanks, our M1s that have been created. Over here in the Op4 position, we can actually see a large number of Op4 in this particular scenario. That's what we can see here. We have, well, not a large number, but it's about a platoon. And over here we have our mechanized infantry that have also been created. So everybody's in their start position. And so if we go across to the editor, we can actually see, especially in 2D, all of the different maneuver orders that have been created. So if we look here at the mechanized infantry platoon, we can see a trigger and we can see a waypoint. So this is a control AI waypoint. And you don't have to touch any of these. But what this allows you to do, if you wish, is come in, if you're an administrator, for example, and really modify the detail. So for example, maybe you want to change the formation, maybe you want to change the rate of movement, maybe you want to remove synchronization for that specific unit. This is where you can do that. So VBS Plan is creating waypoints and triggers in order to make the workable plan, but there's nothing stopping you modifying that afterwards. And in fact, what I'm going to do in this particular example here is just change the assault behavior for the mechanized infantry, so we can actually just see a little bit of debug information to give us a clue of what's happening in the assault. So now we have our behavior created, we've looked at VBS Plan, we can go ahead and execute the mission. So the assault has started. I've executed the scenario. We can see that our infantry are mounting up in their Bradleys and our M1s are moving into their fire support position. Now in the real-time editor, in the 20.1 release, it is possible to view the plan. There's our plan. At the moment the M1s are waiting at their phase line until the allocated time has passed. And in this particular release, in the 20.1 release, it's not possible to modify the plan through actually editing these maneuver orders. This is certainly a goal for the end of the year, but in the 20.1 release, it will execute the plan that you've laid out. However, it is possible, if we turn off those markings, to come into the editor and modify specific editor objects if you want to change something on the fly, for example, formation. You can do that through editing the waypoints directly. So the M1s here have started engaging. They'll engage with the correct weapon system. In this particular development version though, when they do the support by fire, they're actually going to engage with their main guns. And that's why you're going to see the M1s firing main guns in just a second. But right now, before they've actually got to the support by fire position, they're just engaging with their coaxial machine guns. And very, very soon, the Bradleys are going to debus. The infantry will come out and they'll start to conduct the assault. So we'll just watch this play out just for a few minutes here, and then we'll just have a look at some of the other features that will be in the 20.1 release. So now the infantry have just debussed and they have conducted their path planning, and now they're going to move out towards their objective. So I'm just turning on a little bit of debug information here. So they're shaking out into their assault formation. If we come here, I can turn on some debug information just by doing this. So what we can see here is some debug information added to the screen. These white circles are the locations for each of the squads as they bound forward towards the objective. So they're not all going to just run at the objective kind of straight up the middle. They're going to use a formation, and they're going to keep one foot on the ground, and they're going to bound. And they'll also take cover into consideration where they can. So that's what this debug information here is showing. And you can see that that's exactly what's happening. The vehicles will do their best. In this particular situation, the vehicle is unable to traverse this very thick forest, so it's actually going to move around to try and stay with its respective squad. And they'll start to engage as soon as they have line of sight onto the enemy, although I do suspect that our M1s have taken care of those Russians. So we're quite well advanced now into our plan. The support by fire has actually finished. The M1s now are just sitting there. While the infantry move into the enemy position, I thought it'd be worthwhile just to have a look at some of the other features. You might be wondering about close air support integration, and while it's not in this particular dev build, we are striving to make sure that you can integrate fire support directly into your plan. Within VBS 3 and of course in VBS 4, we do have quite a powerful fire direction center. We can come in and we can place in a gun line at a specific location. So for example, just here, and we can specify the exact number of guns that we have in our gun line, and then we can create that gun line, which is going to create the gun line in 3D. And this will be possible to do directly in VBS Plan. In fact, the icon's already there for it. You can create a mortar section or whatever you need, and will actually appear in 3D. And so everything I'm about to do, you'll be able to do just by having a target reference point in your plan. But obviously we can come in, we can set up a fire mission here, and we can select all of our guns. We can choose a location. We'll try and get this done quickly before our blue 4 arrive on the scene. We can change the distribution. We can change the ammunition. We can set up the number of rounds to be fired per gun. We can define the trajectory, and we can process that fire mission and start the fire mission. So now the guns are preparing, and they're actually going to fire this particular mission, and we can turn on a visualization of that. I think we'll be okay. Our infantry are still kind of conducting their assault, and once the guns have loaded, they'll actually fire, and that's what you can see heading up here into the air. Obviously I've turned on the green lines so we can actually see the trajectory of these rounds. And like I said earlier, the plan for 20.1 is that you'll be able to have a target reference point that calls in fire like this automatically. We support mortars, we support howitzers, we support MLRS as well. So it looks like it's going to be a few seconds before our rounds impact. We'll turn off our fire direction center, and we'll do a close air support strike next. So close air support, we're going to use the close air support editor objects, which is what we have just here. So we'll just come back into, whoops, that was our our mortars just actually hitting the ground here. So let's do a close air support strike now. Come in and edit this. It's going to be an A10, dropping GBU 10s. So really quickly, I've just added that now. And we will see that A10 has been spawned. We can actually come in and view that aircraft. Here it is. We'll lock the camera to it. So this is our A10. Now, obviously, this has just been magically spawned into the mission. Typically, this is going to be used by an administrator, obviously, just to really quickly bring fire onto a target. So we want to watch this actually impact here. So there's our A10, and we should see an impact very shortly from those bombs. We're seeing a little bit of lag because I've got hit lines turned on and some debug turned on, but that was the rounds impacting there onto the target. Okay, so that was our deep dive into VBS Plan. I'm just going to bring back the slides quickly now, and we will get into the last phase, which is going to be VBS Control. So I introduced this yesterday. We have built new artificial intelligence from the ground up to support VBS 4, and it's the VBS Control AI that you see driving that entire scenario that we built in VBS Plan. So today I'm quite excited to introduce Martin Kolombo. Martin, if you can turn on your video, please. So this is Martin Kolombo. He is one of the lead developers behind the new artificial intelligence. And so what I thought would be interesting, we kind of added this onto the agenda, hence this session is going to go a bit longer than the hour. I wanted Martin to just do a deep dive into the AI, talk about the architecture, and also talk about the path planning and the cover system and just some of the detail that we don't usually get to see. So I'm really excited to have Martin here. I'm just going to bring the slides back. And I'm going to ask Martin to talk about the architecture. Then Martin is going to play a video recording and talk over it just as we do the demonstration. So this is the last session. It's going to run 20 to 25 minutes, and then we'll get into the question and answers. All right, so I'm going to turn off my video. Martin, over to you.
Thank you, Pete. Hello, everyone. Where I would like to start is just with a little bit of context of where does VBS Control fit in the overall VBS 4 architecture. We'll go over this very briefly. Essentially, VBS Control is made out of 3 parts. There's the behaviors themselves, which model the doctrine, which we see in VBS Plan or in the systems like Civilian Pattern of Life or AI on Rails. And this is entirely based on behavior trees built in VBS Control Editor. Then there is the AI library, which is our core module that implements the concepts like navigation, covers, as well as the API for the behavior trees and for the simulation SDK to access, to modify or build these behaviors. And we will go into a bit of detail in the session today on that. And then what is important is this module connects through a C++ API to our VBS 4 simulation engine or to the VBS 3 simulation engine, or potentially in the future it could connect through that same API to other simulation engines than ours. So this is just a little bit of context to get us started. And what I will do now is I will actually present the deep dive video here. And I will turn off my video so that you can see the video full screen. And what I will actually do is I do not have a voiceover on the video, so I will just talk through it. So I might pause or skip through to make the presentation a bit clearer. So where we start is Peter covered VBS Plan in his session. So we start with a very, very simple VBS Plan scenario here. It's literally just a single armor platoon with a move order. And you do see another armored section in the back there. We will get to those later. And what I will do in this video is I will just start by giving this armored platoon a move waypoint. They are now paused so that I could go on with the demo at my own pace. So I will use the debug UI to just give them a move command along the original movement path. So here I am just assigning that to the lead tank. And we will go in depth on their path planning and kind of how they achieve the move inside our environment. So since this is a armor platoon, I'm just selecting the armor platoon move behavior, just going in with the default options and hitting OK there. And we will see in a second that the tanks will shake out into formation and start moving. But what we will do here is we will go into our debugging panel, and I'm going to turn on some debugs to better visualize how the AI is processing the terrain. So I am turning on the path planning debug. I am toggling on the vehicle nav mesh, and we're just going to adjust the display radius a little bit so that we can see the information clearer. And what you see that did is it enabled these pink and red lines on the environment. And what these give us is it's essentially the drivable surface inside the simulation. You see the red lines essentially are areas where the vehicles cannot pass because there are obstacles, while the pink denote the drivable area. You also see each vehicle has a blue line from it, and this is their path towards the objective. So you see on the lead tank there, the path is all the way towards the end of the move objective. On the tank on the right, he is just keeping information, so he's just planning a little bit in advance. And what we actually see in this instance is the area that they had to drive through was too narrow for the whole formation, so the two sections split, and you see kind of the section on the right keeping together, the section on the left keeping together, and driving around that little outcrop of a forest from a different side while navigating between the obstacles. So this was just a very, very brief demonstration of the basic nature of our path planning system and how you can view the information that the AI actually uses to navigate. Here what we can see is, again, this gets generated for the whole terrain on the fly. So you see it's around the forest everywhere, essentially, not just where the AI drove. And what we have here is just a terrain that has been procedurally generated. So I did not have to do any edits. I did not have to actually calculate anything or process anything offline. I just load up VBS 4 and the information is already there. However, this is a static piece of terrain that was procedurally generated. What we will show here, and I will just get the plan overlay out of the way so that we can see it clearer, is how this information is dynamic, because in VBS 4 you can do many different things. So what I just did is I just placed a house using the standard VBS mission editor, and you see that that house immediately updates the navigation information. So there's that obstacle around it, and now I am ordering the vehicle that we had there before to drive through that area. So this is just a CV9040 APC, and I'm just ordering it to drive across the house, and you can see that that information is immediately taken into account, and it treats it as an obstacle, even though I've placed it just moments before. You also see it, of course, avoids the tank that drove there earlier, even though that tank, it doesn't have any obstacle area around it, and that's because the tank is a dynamic obstacle, so it is using dynamic collision avoidance to navigate around vehicles as well, and we will see more on that in just a minute. You see, as I move the building around, the information updates again, and of course the tank is always using the most up-to-date information to move around. This would, of course, also work for destruction, dynamic placement. If a vehicle places down some obstacles, like you place down a razor wire in the scenario or build some trenches or tank obstacles, these will get recognized by the path planning. So that was for static obstacles that get baked into the nav mesh, and now we will just talk a little bit more about the dynamic collision avoidance. So just for clarity, I am again showing how the APC can avoid essentially other vehicles in the scenario, and this will work, of course, for infantry as well, or for civilians. They will dynamically avoid those. And this was quite a simple scenario, just avoid one vehicle avoiding another stationary vehicle. So now what I will do is I will just copy paste the CV9040 a couple of times in the scenario, and I will have the three vehicles move against each other at odd angles, and we will see how the AI deals with that situation. So all I'm doing is I'm issuing the default convoy behavior with the off-road path planning, and I am having all three vehicles meet in the middle like this. And you see that they resolve even that situation using the dynamic collision avoidance quite well. They will slow down or turn a bit to the right or to the left as they need to avoid collision with each other, and they each reach their destination. So that's it on the vehicle path planning in a nutshell. This was a very, very brief overview of the systems that we have there that allow us to have results in the dynamic VBS4 environment and basically be able to deal with the high fidelity of the terrains that we have, where there's a lot of objects and there may be a lot of other vehicles and a lot of other infantry moving around or just stationary in the scene. So now we'll skip the video forward and we will move to the next scene I had in this scenario when I recorded the session this morning. And this will not be on vehicle path planning, but we will look into one of our tactical systems that the AI uses to execute the behaviors. And it's worth mentioning here that, again, this is a procedurally generated version of the terrain where all I did is I used VBS Geo to place down a couple of objects like these HESCO barriers, these sandbags, the vehicle rack, the road, and so on. And what we will be showing here is an example of a defensive behavior position for a fire team. So this is quite a small scale example, it's worth saying, but these are the same concepts that we apply to our fire team, squad, platoon behaviors, and there is no reason why we couldn't take it higher in the future. And Pete did mention that we successfully ran an experiment with battalion versus a brigade using this same technology. So what I am doing here is I am issuing a defensive order to take cover for this fire team of soldiers. And when I did that, you did see they moved into various positions of cover in the environment, and you see some debug lines aiming at this cover threat arrow in the background. So what this is doing is each of them is finding a position that can have line of sight on the enemy and that provides them some protection against enemy fire if that fire comes. So here I'm highlighting the threat that they are taking into account. For simplicity in this scenario, there is just one threat, but the system can take multiple threats into account while choosing positions. And what we will show now is we will illustrate how the behavior actually works and what sort of information it deals with. So I do have a single Taliban soldier here that was hidden behind this wall. I am bringing him out now. Nobody is shooting because everybody is on hold fire behavior, just so they can go on with the demonstration. And I just ordered the OP4 to fire a burst at the cover. And you did see, it might have been a bit hard to see, but you did see the blue 4 went into various positions of cover on their own as a reaction to the enemy fire. We will run through it again in a few seconds. I will turn on the shot trajectories debug so it's clearer to see. So again, you've seen the bursts impact the cover, and you've seen the soldiers react to it by one of them going prone behind the sandbags, the soldier in the middle moving to the left behind the barriers, and the other one moving to the right on his side of the cover. So why this is happening is essentially our cover system is not just a set of fixed points, but there's a lot more information in there that the AI can take advantage of. So again, we will turn on some debugs to make everything more obvious to see what is going on. So I've turned on the debug for the cover system, and we suddenly see these blue outlines around objects in the environment, and we also see the navigation information, this time for the infantry. And what the blue outlines give us is these are essentially the polygons that the AI sees when they look for points with good cover in the environment. So we see some low cover around the sandbags, we see higher cover around the HESCO barrier to the left, and we see that the position of the soldiers corresponds to this information. And here I am just illustrating that essentially the system is giving us two positions because it is dealing with the whole width of the cover, so it knows that to move to the cover means to move left, and to move to see the enemy means to move right. Here I am just showing essentially all of the points, all of the objects in the area give us some measure of cover. You see that fence in the back was yellow because that's a very poor cover, but other objects might give better or worse protection depending on what they are. So here what I'm just doing is showing that the system indeed is quite dynamic. So I'll move the threat around a couple of times. And just I am updating the order for the soldiers to reposition. In this case, they use the trees as covers. You see 3 of them took covers behind the trees. One of them simply just goes prone on the ground if there is not enough cover to go around. Now I am moving the enemy position all the way to the road, and I will ask the soldiers to reposition again. And you see now they utilize this sandbag on the correct side, with one of the soldiers moving all the way to the left to take cover behind the building that is there. So this probably gives a good enough picture of how dynamic the system can be in the terms of it can deal with different directions of enemy threat and also different positions within the environment. And however, again, we are just dealing with objects that were placed statically and that the soldiers take into account when running this behavior. What we will do now is, again, we will show the concept of, as we edit the scenario, the AI is processing all of this information on the fly, and it can operate with it as well. So I had this wall prepared, and this is just a standard object that I have placed in the editor. And as I am moving it around, you see not only the path planning information changes, but also the cover polygon moves with it as well. And as I move it to form part of this barrier, you see the cover polygons actually merge together. And if I order the soldiers to take cover now, they will reposition based on the based on the information that is there right now. You did see them actually swap places. The reason that is happening is this is a demo behavior that is set up to recalculate all the positions every time. So they do not try to minimize movement. They just find optimal positions as a whole fire team. What I did here now is I've actually moved the wall to block line of sight to the enemy for one of them. And again, I recalculated the system, and you see they adjusted again. So now they have moved so that this wall doesn't obstruct their lines of fire. So one of them moved further back to find a covered position behind the trenches there. And what this illustrates is essentially not only how they can take what protects them into account, but also that they take other objects that may be blocking their line of sight into account as well. So what we will do now is essentially we will talk more in depth about how is it that they are choosing these positions, because some of the results that you may have seen here we might want to tweak. We might want to adjust how they react to different positions and why they choose some over others. And to do that, I will just pause the video here. We will need to go into the VBS Control Editor, where I have the behaviors for these soldiers. So VBS Control Editor, for those of you that haven't seen it before, it is our development tool that can be used by integrators to build your own behaviors for VBS 4 or VBS 3, and that we use ourselves to build all of the behaviors for VBS Plan, and that has been used to build this demo as well. So what I am showing here is a set of behaviors that is purely covering the demo, and we now have an example of a behavior for individual soldier to run into cover. So you see this is a visual programming language. The behavior is made out of sequences, decisions, and other type of control flow nodes. So you can see this behavior is for a soldier to bound or run into cover. So if there are enemies, they will bound from position to position, engaging them on the run. If there are no enemies, they will just run to cover. We didn't see them engage because I have them on hold fire, as you will see later. And once they are in the cover, they will engage from the cover. What we can do as well with the control editor is we can at runtime attach it to one of the AI and visualize what is going on. So I did this quite quickly, but what I did is I just picked one of the soldiers in the scenario and attached to him, and we now see this blue highlight showing that this soldier is in the engage from cover behavior. We will go into that behavior in just a minute. I actually detach here to make this more obvious what I did there. So again, we are attaching to one of the soldiers, AI1 in this case. We see the highlight again. This is on the fly showing which behavior is being executed. We are going to go in there now into this behavior just by clicking on the node inside the editor. And here we see another behavior tree, this one with a few more decisions in here. And that's what the soldier is doing right now. There's a few more highlights in this behavior, and that's because the options on the left are actually false. That's when the soldier would need to reload, when he would need to hide from enemy fire, which we have seen before, or when he needs to look for a target. And we see the option that is active is the option for the soldier to fire. And you see here the hold fire is highlighted because that's what I have them set in the scenario. And you see the colors flash because this is actually running live, and as the behavior is executing, it updates the real-time status of the behavior. So every 3 seconds this will cycle through because it's set to a 3-second wait time. What I did now is I just added a breakpoint really quickly just to show you that this comes with a full suite of debug tools. When you add a breakpoint, you can inspect the variables as well. You can step through the behavior like this. I am just pressing F11 in the tool to step through the behavior frame by frame, really, to inspect what is going on. So this is a really, really powerful development tool for if you want to build AI for VBS, either build a whole set of doctrine like we did for VBS Plan, or even just build something small for a single scenario. So we will not go too much in depth into how do we develop with VBS Control. I think the video will end it here. So I will just remove the breakpoint and hit F5 to continue to resume and detach from the AI. But what we will illustrate is just one example of how can you use this to change a behavior, and we will also use it to further illustrate how the cover system works in the scenario that we have seen. So this is the behavior tree that controls the fire team to search for the cover positions that we did see in the scenario. What I will do now is I will go into the find covers node in this behavior. This behavior is really simple. It just finds the positions and orders the soldiers into them. So we are going into the first node that is responsible for finding the right positions. I'm just going to expand the script that is inside this node here. And this is Lua, this scripting language that we use. We use it for essentially whenever you need to calculate anything inside the behaviors, pull some information from the terrain and pass it to the AI, you would write a Lua script. Lua is really quick to learn and to write with, very efficient. And the script here does a couple of things. Essentially, in the beginning, we just go through all of the soldiers. We find their ideal positions in formations. We define the position, the area where we want to look for the cover. And in the plan behaviors, this is all already built in. Here we are just going through the steps that kind of make the AI tick. And what is the important information? The important piece of information here that we will focus on are the parameters that go into the cover itself, into the cover system to find the final positions. So you did see there's threats, there's the area, there's the ideal formation positions, and then there's a set of weights, a set of parameters, where we will look at 3 weights that control how the final position is chosen. And these 3 weights are distance, protection, and line of fire. And essentially, it's a combination of these 3 weights that informs the system how important is it that I move outside of position if I can find the better cover. Should I move outside of the ideal position to get into a better cover? Should I move outside of the ideal position to get a line of fire on the enemy? And what we see as values here is kind of a reasonable default that we use, which has equal value to protection. So protection means being behind one of these blue polygons, of course, as it gives to the line of fire, which we have seen before that they do take it into account. They will reposition to be able to see the enemy. And then we are quite lenient with the distance because it makes them find better positions more often rather than stick to a precise formation. But what we will do now, just for the sake of demonstration, is we see now the distance setting allows the soldier to run quite far from his comrades there. So we are just going to increase the distance parameter to -2, and that's a 20 times more severe penalty for running 1 meter out of position. All I did here is I changed the number. I hit Control S to save really quickly. And now we will get that updated behavior into the system just by clicking on Reload Behaviors live. No need to recompile anything, no need to even restart VBS4 or the mission. I just made the change. And now I will click on Take Cover again. You did see the debugs disappeared when I reloaded the behavior, and it's because everything restarted. So nobody was doing anything, and the debugs are drawn by the behavior as well. And now when I ask them to take cover again, we see a very different result. So now they very much prefer to stick together in roughly a line with even spacing than running out of cover. They are willing to run into cover if it is very close. So when I adjusted their position, you see they moved behind the sandbags, but now they very strongly prefer to stay in formation over moving really anywhere. So -2 is a very, very extreme value that I chose to illustrate the point of how the system affects the decisions of the AI, and that you can make a change really quite quickly and see the results. So now I'm just going to change it back to -0.1. So I did that. We will again just save, click pressing Control S there. Now I forget to reload, so I press take cover and nothing different happens. But when I reload the behaviors and press take cover, we will again see them to get into the original positions where they were before. So behind the sandbags on the right and behind the building on the left, basically reverting back to the behavior that was there. So that about wraps up the cover demo. What we've seen is, just to recap, how the information in the terrain is processed for the AI. And again, this is all already taken into account by the VBS Plan behaviors. So a fire team in VBS Plan will use this information to fight inside the simulation. We have seen how the various parameters can affect the system and what parameters the system even takes into account. And we have seen just very, very brief overview of the development tool VBS Control Editor that we have used to make this, and that you can use as part of the simulation SDK as well. So the last part of this demonstration is, again, just showing something from our dynamic nature of the path planning systems. I'm moving to yet another area in the terrain, and we have seen dynamic obstacles, but now what I want to show is that we can also dynamically build up pathways. It's not just obstacles. It's not like the walkable area is fixed or the drivable area is fixed in the environment. So what I have here is I just have a half-built pontoon bridge. Again, this is just objects that I placed in the VBS mission editor. We will just adjust the debug to, again, show us the vehicle navigation data. And you see there's a little bit of a drivable area on the bridge. So what I will just do is I will move the third segment of the bridge into position. As I move it, you see the navigation data updates at runtime. So if you have a bridge layer, lay a bridge in VBS 4, then this will happen. And now I'm just going to order the tank across, and it will find the path correctly. And this is, again, just a standard behavior, nothing special there. And immediately the tank finds the path, and it will drive across the bridge safely. Or it drives in a rather speedy way, so it will jump a bit, but it drives across the bridge and finds the path quite easily. And that is pretty much it for our demo. The only thing that I will do now is just send the tank back across, and that wraps up the VBS Control deep dive. So back to you, Pete.
Thank you very much, Martin. We'll just let the tank run, let the video run here until it stops. So we've got a lot of questions there on that. So I just want to kind of clarify. I did ask Martin to go deep, which is why we were looking at Lua script. I will just spend a second before we wrap for questions just describing how all this fits together. So the vast majority of VBS4 users will never see the VBS control editor, will never have to edit Lua script. Basically, we expose the parameters in the waypoints and in the maneuvers. So you don't need to worry about that too much. If you have a US Marine Corps ORBAT, we'll firstly predefine formations and rates of movement and such, and then we will expose in a very easy way an ability for you to change that. So I'm just going to stop sharing the video here. So so that's the first thing I want to say. But if you're a developer, or if you're you're into scripting, or you want to go a little bit deeper, you can create your own behaviors. You can modify our own behaviors. And we will provide to you a set of examples to get you started. So most VBS4 users will be up here just changing the parameters like formations and such in the waypoints in the editor. If you want to go deep, then you can do that using the simulation SDK where the VBS control editor is included. Okay, so that ends it. I did warn you all that we were going to go over time, but I'm sure you all agree it was worth it. Martin's excellent presentation there, I think, was really illuminating. So what we're going to do is now do questions. Now, we have a lot of questions to get through. I will not be offended if anybody drops off at this point. I guess we're going to be answering questions for 10 or 15 minutes. Feel free to hang around, feel free to leave. We will be uploading the session to YouTube, and we are capturing all of the questions. We received over 100 questions yesterday. We're going to be working through those and posting that in some kind of blog on our site. So if you drop off, that's okay, no problem. Otherwise, I'm going to ask the guys to start presenting me with questions, and we'll move through that.